Welcome everybody to Unit 4. This is the first video in that unit. This one is called video number 23, Scale of Objects. You were going to meet Miss Andalina. She was our math teacher last year on team. All right, here we go. So we're going to talk today about atoms and cells, and size is very important, and I brought her because that has to do with math. I'm going to prove it to you, how big and small they are. So here we go. All right, hold on, YouTube.
This is a man-made motor, a motor so small that more than 6,000 of them would fit on the head of a pin. Welcome to the world of the nanometer, a unit of measure that is 1/billionth of a meter.
A nanometer is pretty small. One of the best analogies that I like to use is to compare it with a human hair. If you take a hair off of the top of your head, you can see that it's very thin. And now if you take something that's 100,000 times thinner than that, that's a nanometer.
The ability to observe and construct things this small is at the heart of nanotechnology. The fact that you can customize nanomaterials' unique behaviors has already turned nano into the buzzword of the decade. Some researchers predict nanotechnology could lead to faster computer chips, tiny medical devices that repair clogged arteries, and new filters to clean water pollution.
Different now is that we have the ability to look on the nanoscale and see what's happening. That gives us an ability to design materials rather than to just find them by a kind of accidental process.
But understanding and controlling how nanomaterials act can be tricky.
Nanoscale means super, super small, and it's very important in chemistry because we're going to start with the smallest piece of matter there is, and that's the atom. Not confused with our atom we have in class that's nice and tall, but something that is super small. And so can you say this for me? How would you say that?
I would say 10 to the negative 16th power.
Correct, and that is very small.
Very, very small.
Very small. It is that many zeros small. That's really small. So this would be very cumbersome to write as a very long number because you don't want to be writing all that out. So that's why we write it in, what do you call this form here?
Scientific notation.
Scientific notation.
And it's also better because if you miss a zero or add an extra zero, your answer will be wrong. So writing it in scientific notation leaves less room for error.
Perfect. Kind of like texting.
Yeah.
So scientific notation is how scientists and mathematicians handle really big numbers because you don't want them taking up a whole page. It is also called standard form. Do you call it standard form?
I do.
Oh, you do? I just learned that when I was putting this together. How cool. All right, so I'm going to let you read this one, and maybe you can say it more math better than I can.
All right.
Okay.
So when you have a positive exponent, you move your decimal point to the right, like we learned in math class, because it's like multiplying by a power of 10. And when you multiply, you get bigger, so you move your decimal point to the right. So when you have a negative exponent, you move your decimal point to the left, and that's because you're dividing by 10, making it smaller. So smaller objects, your decimal point goes more to the left, and larger objects, your decimal point goes more to the right. So we have the number 72 million, and to write that in scientific notation, remember we have to move our decimal point to make our coefficient between 1 and 10. So we move it in between the 7 and 2. We move it 7 places, so that's where we get our exponent of 7.
Perfect. So very good. So these two things are exactly the same number, correct?
Absolutely.
Okay, but this one's way easier to write. All right, we'll go with that. All right, so Miss Andalina has a few examples. She's going to run through you from going from scientific notation to, what do you call that?
Standard form.
Standard form. All right, hold tight.
3.978
Perfect.
times 10 to the 6th power.
Perfect. Okay, so write this down, please. We're going to do this as a practice example. Go ahead.
So I'm just going to rewrite it underneath. So I'm just going to write the number underneath so we can work with it. 978. So remember that our exponent tells us how many times we move our decimal point.
So this is a positive exponent,
It
right?
is.
So I'm going to the, that
Right.
way?
Mhm.
To the right,
So
okay.
we move it 1 place, 2 places, 3, 4, 5, 6. And remember when there's no numbers, we go back and add zeros.
Perfect.
So our final product would be 3,978,000. And that would be our answer in standard form.
I would like to have that much money. That would be okay.
That would be great.
Excellent. All right, and let's do your, so we have a second example that we're going to do again just to show you the other way. So we did a positive, a big number. Now let's talk more on like the atom scale. So we're going to go smaller.
All right. So we have 9.84 2 times 10 to the negative third. So I'm just going to rewrite it down here so we can do some work.
So that's always a good idea, to write it below before you start working with it.
That way it doesn't get into all the other numbers when
Okay.
you're moving. You don't get confused.
Excellent.
So this is where most of you forgot what to do. You thought, oh, -3, I'll just add 3 zeros. Don't forget we need to move our decimal point from the coefficient first. So that's 1, 2, 3. So then we add 2 zeros. So this would be our answer in standard form.
So this is a very, very small number.
Very small.
Very small number. Excellent. All right, very good. Hope you guys enjoyed doing a couple of examples with Miss Andalina. Remember, you're doing very, very large numbers or very, very small. And in chemistry, we're going to stick with the wicked small numbers. So summary time, we would like you to write your summary, of course, and I would like you to say a little something about scientific notation and how it's important to chemistry. Miss Andalina showed you how to, so they could write out the steps maybe, that would help. And make sure that we understand that the negative exponent is smaller and the positive one is larger. And when we're talking about chemistry, we're going to stay in the wicked small area. So you guys say thanks to Miss Andalina, and we'll see you guys all in class.